Hi Geometry, this is Unit 5, Lesson 7 on page 563 of our workbooks. So in this problem 7.1, we're being given a cube whose side length is 1. So this is my original, and it's been dilated by several scale factors to make new cubes, bigger or smaller depending on the scale factor. As a reminder from Unit 3, when my scale factor is between 0 and 1, that's a reduction, my cube would get smaller. If my scale factor is 1, that's an isometry, my cube stays exactly the same size. And when my scale factor k is greater than 1, it's an enlargement, and my cube will get bigger. So my original cube that I start out with has side lengths. There's six faces, and all the side lengths are 1. So that means my original volume for this problem, which is length times width times height, is 1 times 1 times 1, or 1 unit cubed. So let's take a look at number 1. It says, what scale factor, that's k, I don't know it, will the volume be the dilated cube be 27 cubic units? This is the image volume. This is the one that comes after. So remember from our last class, the image volume is equal to the scale factor cubed. That's how the volume changes, by the scale factor cubed, times the original volume. So let's substitute in what we know. The image volume is 27 equals the scale factor cubed, that's my unknown, times the original volume of 1. Technically, we need to divide both sides by 1. I'm going to do it just this one time because it's really an unnecessary step as far as writing the work. But I do need to isolate k cubed. So if my original volume was something other than 1, it's really important I divide by that number. But when I do that, I just get 27 equals k cubed. This is where, in order to solve for k, I need to take the cubed root of both sides. I need to take the cubed root because I need to cancel k being cubed. I need the cubed root to cancel the k cubed. And so I need to move over here. Sorry about that. Let me rewrite. I have the cubed root of 27 equals the cubed root of k cubed. So on the right side, I would have just k. On the left side, I would do the cubed root on our calculator. We're going to go over that in class in Zoom. If you need help with that, please come to office hours if you don't know where that button is on your calculator or how to do that on your calculator. But you're going to get 3 on your calculator for your answer, because 3 times 3 times 3 is 27. So let's continue on with 2. Again, my image volume is 1,000 cubic units. So I'm going to put 1,000 in for my image volume. That equals k cubed times 1. Technically, I'm going to divide both sides by 1. I get 1,000 equals my k cubed. So now let's take the cubed root of both sides. Again, this is on your calculator. If you're unsure how to do a cubed root on your calculator, please bring your calculator to office hours and I'll help you there. The cubed root of 1,000, my calculator will give me 10. So k, my scale factor, is 10 in this case. So number 3 says estimate the scale factor that we needed to make a cube with an image volume of 1,001. So let's put 1,001 in for the image volume. That equals k cubed times the original volume. Divide both sides by 1. 1,001 equals k cubed. Take the cubed root of both sides to solve for k. And when I do this on my calculator, I get 10.003 for my scale factor. So then let's look at the fourth one. It says estimate the scale factor that would be needed to make a cube with volume 7 cubic units. This is my image volume. Let's substitute the 7 in for my image volume. It's equal to my scale factor cubed times my original volume of 1. Divide both sides by 1. 7 equals k cubed. Let's take the cubed root of both sides. When you do 7 cubed on your calculator, you get the cubed root of 7, 1.9 equals k. So let's take a look at the next page. Actually, if you could go one more page to page 565. Let's take a look at these two problems. Let's read the problem. A government agency is redesigning a satellite or object that goes into orbit around the Earth. The surface of the satellite is covered by solar panels that supply the satellite with energy. The interior is filled with scientific instruments. The current design of the satellite has a surface area, so this 5.4 feet squared, this is my original area, my original surface area, and a volume of 1.2 cubic feet. So this is my original volume. It's important I know what those are because I'm going to put them into my equations. So number one says if the agency wants to increase the surface area, so this number, this 21.6 square feet, this is my image area. It's the area that comes after. It says what's the scale factor they need to dilate the satellite to make it bigger. So remember our equation, the image area equals, be careful, how does area change? Image area. It changes by the scale factor squared, so times the original area. Let's substitute in what we know. That is 21.6 equals k squared times the original area of 5.4. Now I need to solve for k. So my first step is to divide both sides by 5.4. I need to move it to the left and get my k squared by itself. So let's divide both sides by 5.4. And since I ran out of room, I'll write to the side. 21 divided by 5.4, 21.6 divided by 5.4 is going to give me a 4. On my left side, my right side, the 5.4's cancel and I get k squared. To get the k by itself, I need to cancel the k being squared. I'm going to do that with the square root. When I do the square root of 4, I get 2 equals my scale factor. So when my satellite is dilated by a scale factor of 2, all my dimensions get twice as big, then my area gets 4 times as big, and that would be the answer to number 1, when my scale factor is 2. So let's find out when the volume increases to 4.05 cubic feet. This is my image volume, the 4.5 cubic feet. So when I set up my equation, I know the image volume equals k cubed times the original volume. So I know that 4.05 is equal to k cubed times my original volume up above in the problem was 1.2. So again, I'm trying to solve for k. I need to isolate the k cubed. So let's divide both sides by my 1.2 to get the k cubed alone. On my left side, when I do my division, I get 3.375. So next, I need to solve for k. That means I need to cancel the k being cubed. I need to undo that. So I'm going to take the cubed root of both sides in order to do that. So on my calculator, when I do the cubed root of 3.375, I get 1.5. And when I do the cubed root of k cubed, it cancels the k cubed, and I just get my k. So when my scale factor is 1.5, when my dimensions get 1.5 times bigger, my volume will increase 1.5 cubed times to the 4.05 cubic feet given in problem number 2. Thank you for watching. See you in Zoom.